All right, guys, now we're going to look at interpreting topographic maps and satellite views. Back when we learned about this, we called these topo maps. So let's start down at the bottom at this section right here. And it says that topographic maps show details of landforms, contours, and most importantly, elevation through the use of contour lines. These little images right here are what the topographic maps will look like, those squiggly, round, kind of funky shaped lines. And these maps also show vegetation, roads, man-made structures, etc. Another type of map that we have are satellite images. These are ones you're probably used to seeing on things like Google Earth. These are the basis of topographic maps. They look probably something like this. Here is a satellite image of Breezy. There's our track, there's Rodriguez behind us. So this is a satellite image. And these satellite views are valuable in studying past geologic events, as well as studying and predicting weathering. And weathering is a chemical or physical process that changes the characteristics of rocks on the Earth's surface, as well as erosion, which is weathering that the surface, soil, and rock are worn away through things like glaciers, water, and wind. And then deposition, which is the process in which sediments, soil, and rock are added to a landform or land mass. Now, you guys don't have to write these definitions unless you want to. I just wanted to review what those things meant. So these events could occur in the future and change the landscape and environment. Satellite imagery and topographic maps are important in showing these processes. Features that they will monitor are things like deltas, alluvial fans, canyons, and glaciers. All of these things are related to that weathering, erosion, and deposition. So when we look at basic topographic map symbols, we have contour lines, and contour lines connect points of equal elevation. Any point that's on that line is going to be the same elevation. We also have index contour lines, and they are darker, and they mark special elevations, like every 100 or every 50. Spaces between lines are referred to as intervals. So between these two lines right here, the interval could be 10. So every line would be 10 meters. So 10 meters, 10 meters. This allows us to measure the distances between different elevations. On some of our maps, we will have these V-shaped contour lines, and they indicate the presence of a stream cutting a valley. Now, if we have water running over time and over long periods of time, that water is going to erode the surfaces around it, cutting into the land, and it creates this valley on the topographic map. And so these points, when you see several of them all together, the points will make an upside down V, and that V points, the top of the upside down V points upstream. So you can see which way the river flows. The river or stream will flow down towards the opening of the V. So when we look at the spacing of contour lines that are close together indicate the elevations drop suddenly, making it a steep slope. There's a very quick change in elevation. Contour lines that are far apart indicate the elevation drops gradually, making it a gentle slope. And then lastly, to find the distance between points, you're going to subtract the elevations. And we'll look at that here in a few minutes, or here in just a second on our example. So here we are, an example, and this is the one I'm going to do with you, and I'll help you set up 2, 3, and 4. So on this one, the points labeled W and Y on the topographic map below show the campsites of 2 families. Each family hiked to the elevation on the map marked X. And the arrow shows the path taken by both families. What was the change in elevation to the nearest 10 meters for the family that took the steepest path to point X? And it wants you to record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. We've still got to get practice on these gridables, guys. You've got to put it in the right spot. So if we look at this question, they gave us W and Y, and it gave us their elevations. And we were wanting to know who took the steepest path to get to X. So we know that point W starts at 560. This is because if we start at 500 at this contour line. It's an index contour because it's bolder and labeled. We're going to go an interval of 20 meters. So starting at 500, 520, 540, 560. So W is at 560. Now to find out family Y's starting point, we look at their contour line. Here's another contour interval right here, 440, and our interval or contour line, which is 440, and our interval is 20 meters. So 440, 460, 480. So our Y is at 480. Now, we need to decide who took the steeper path. Remember, steeper slopes mean closer contour lines. If we look at W, these contour lines are pretty far as being spread out. While on point Y, their side looks much steeper. So we're going to go with point Y. The steepest path was Y. Those lines are the ones that are closest together. So to find the distance between points, we're going to subtract the elevations. Point X is at 600 and point Y is at 480. So our family needs to travel from an elevation of 480 to 600. To solve for this, we need to subtract. So 600 minus 480 gives us 120. If subtraction is not your strong point, another way you can do this, start at point Y and count by 20s. 20, 40, 60, 80, 100, 120. They've reached 120 meters as their distance. So now we would bubble in our griddable, making sure that we pay attention to where the decimal is located. I know a lot of you guys are struggling and starting it over here. If you put 0, 2, and 1, the answer is wrong. Make sure that this number starts before the decimal and bubble in your answer. So the correct answer for this one was 120. I'm going to help you guys set up 2, 3, and 4, and then you'll work on them on your own with your partner. Okay guys, let's look at number 2. The satellite image below shows a ship channel between South Padre Island and Boca Chica Beach in South Texas. Right here is the ship channel where ships pass through. Sand is sometimes removed from the ship channel through a process called dredging to make it easier for ships to travel through. So they come in and they remove this sand to make the ships easier for them to travel through. So they've moved sand out. Recently, sand from the bottom of the channel was moved to area beaches. So when they move this sand out, they add it to the beaches. And they're wanting to know, without this transfer of sand, what would most likely occur in this area in the future? What do you think would happen? So I want you to think about it. They're not moving sand out to make it easier for ships anymore. They're not moving it out to make it easier for them ships to move through. And ships probably need a pretty decent depth for these larger ships. They're also not moving the extra sand to the beaches anymore. So the beaches are receiving less sand. Think about those things when you answer this question. Number 3 says a student stands at the point marked X on the topographic map below. X is located right here on this contour line. What height in meters must the student climb in order to reach the top of the hill? And we have another griddable so you guys can get some more practice on answering these griddables. So on this question, a problem that kids most of the time come across is they use 300. Notice 300 is a contour line, but we have a special symbol, and this special symbol means the peak or the highest point of elevation. So you're going to need to use this number along with the elevation of point X to solve this question. What I recommend doing is counting your contour interval of 10 from 0 to here and then subtracting. And then number 4, the satellite photograph below shows a large meteorite crater that is 1,200 meters in diameter and 170 meters deep. This crater is located in a flat, arid part of northeastern Arizona. how will this crater most likely change over time? So my advice here is arid means dry or little rain. They're in Arizona. And a crater, it means it's going to be going into the ground. It's not a hill, it's going into the ground. So we're wanting to know how it will most likely change over time. And I want you guys to think about weathering and erosion and what it could do to the edges or this crater in general over time in a dry location. All right, guys, well, I believe that covers it all. Go ahead and work on your finishing up these questions, and great job.